Alright, 5.7, the binomial theorem. I'm going to do the best I can to talk about the binomial theorem in a short, succinct manner. Binomial theorem is just a really cool thing to me. It leads to so many other cool patterns in math, but I'll do the best I can. So what we're going to do is we're going to start off with Pascal's triangle. And Pascal's triangle will be the numbers that we use for the coefficients for expanding binomials. So basically the binomial theorem tells you how to expand a binomial. So Pascal's triangle is made up of this pattern. You start with 1 at the top, and then you next row down is 1 and 1. And the next row down is 1, and then you add these two together to get 2, and then you bring down a 1. Okay, then the next row down is you bring a 1 here. These get added together for 3. These get added together for 3. These drop, that drops down 1. Now there's a reason why this works. There's a block walking argument that you can do. Like if you start here at this point, how many ways can you get to this point? So there's 3 ways. You could go 1, 2, 3. You could go 1, 2, 3. You could go 1, 2, 3. So there's 3 ways to get there. So you go 1, 2, 3. Like if these were blocks, street blocks. So if there was like roads in between here. So you go 1, 2, 3. So you can't go across this way to get to this point, but you're starting here, stopping there. All right. So then if there's 3 ways to get here and 1 way to get there, then underneath there'd be 4 ways to get down here. So it's 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. And this just goes on forever and ever. There's all kinds of cool patterns in Pascal's triangle. Like here's the counting numbers, the triangular numbers. If you add the numbers across, you get like powers of 2. I mean, this thing is loaded with stuff. So what we're going to do is we're going to use the coefficients of Pascal's triangle to expand things out. So we're going to have x plus y to the 3rd power. Okay, so you see the 3 here, and then you look here at the 3 there. Those are the coefficients that we're going to use to expand this out. So if you multiply this together 3 times, it's going to be x times x times x. So it makes sense that it's 1x cubed plus. Then you bring in the next coefficient. There's the first coefficient. Here's the next coefficient, which is 3. So it's 3x squared. And then the y would come in, y to the first. Plus, the next coefficient is 3. The x drops down a power, 1, and the y gains a power, 2. Plus 1, and then y times y would be y cubed. So you look for all the stuff here to make sure you did this right. 1, 3, 3, 1. So we have the coefficients. X to the 3rd, x to the 2nd, x to the 1st, no x. Then you have no y, y to the 1st, y to the 2nd, y to the 3rd. Also notice the sum of the exponents always makes the number out here, and it's all the combinations of that too. So this would be like 3 with 0, 2 and 1, 1 and 2, and then 0 with 3. So it's all, there's so much beautiful patterns to this. Now I'm going to do the next one down here, which would be 4, 6, 4, 1. So that would be x plus y to the 4th power. Now, would you like to multiply this out and FOIL it all together and stuff? No. So a pattern is really nice for this. So it's 1x to the 4th plus 4x to the 3rd, bring in a y, plus next coefficient would be 6, 6x squared, y to the 2nd, plus next coefficient 4, x to the 1st and y to the 3rd, plus 1, y to the 3rd, not 3rd, 4th power. I was looking at the last one by accident, but I caught my mistake. So it's 1, 4, 6, 4, 1, 1, 4, 6, 4, 1, so it matches there. And then it's x to the 4th, x to the 3rd, x to the 2nd, x, and no x. And then it's no y, y to the 1st, y to the 2nd, y to the 3rd, y to the 4th. Okay, let's do one more for kicks. So we get x plus y to the 5th power is equal to 1x to the 5th plus 5, x to the fourth, bring in a y, plus 10, drop an x, x to the third, bring up of a y, plus, next coefficient, 10, x squared, y to the third. Next coefficient, 5 plus 5, x to the first, y to the fourth, plus 1, y to the fifth. So they're all there. So let me make sure. 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. X to the fifth, x to the fourth, x to the third, x to the second, x to the first, and then no x. No y, y to the first, y to the second, y to the third, y to the fourth, y to the fifth. It's a beautiful pattern. You can even do this with x plus y to the second power, because it's 1, 2, 1, so it's 1, 2, 1. So it'd be 1x squared plus 2xy plus 1y squared. And those are ones right there. So it's basically just x squared plus 2xy plus y squared. And that's what would happen if you used the old-fashioned FOIL with this. All right, first outside, inside, last. So that's expanding binomials using the binomial theorem, and the coefficients come from Pascal's triangle. And we're now going to expand these two right here. So we're going to do a first. So a is x plus 3 to the fourth power, which is going to be equal to. Now I need the coefficients, so I got to get my paper back here again. So you use the one with the 4 in it, right? It's fourth power, so you look to the 1. It's 1, 4, 6, 4, 1. So it's fifth power, you use the 5. It's sixth power, you use the row with the 6. So it's 1, 4, 6, 4, 1. So I'm going to write that above here. 1, 4, 6, 4, 1. Those are all my coefficients. So here we go. So it's going to be 1, x to the fourth, plus 4, x to the third. Bring in the y, but it's not a y, it's a 3 to the first. So that's the difference. Instead of having a y there, it's a 3. Plus 6, drop the x down, second power, bring in the 3. It's squared now. Plus, the next coefficient is 4. It is x to the second power. No, it is x to the second power, so we drop 1. X to the first power, and then bring in 3 to the third power. All right, plus, and then we're to the last one, 1, and then 3 to the fourth power. All right, so I have 1, 4, 6, 4, 1, 1, 4, 6, 4, 1, x to the fourth, x to the third, x to the second, x, and then no x. And then the second thing, so instead of thinking about it as x and y, think about it first thing and second thing. So the first thing is x, the second thing is y. So the first thing here is, second thing here is 3. So it's 3. There's no 3. 3 to the first, 3 to the second, 3 to the third, 3 to the fourth. The difference is 3 is a number instead of just the variable y. So we can actually figure out what this is using the order of operations. So here's my simplified answer. X to the fourth. Follow the order of operations. So it's 3 to the first, which is 3, times the 4, which would be 12. Okay, plus order of operations says we square this first. So we're going to get 9 times the 6 would be 54x squared, plus 27. 27 times 4 is 108, right? 27 times 4 is 108. Yes, 108 plus 108x to the first, so we don't really need a first there, plus 3 to the fourth power is basically 9 times 9, which is 81. So that is equal to the original thing right here. Well, this would be standard form, right? That's standard form. And if you wrote it out this way, x plus 3 times x plus 3 plus x plus 3 plus x plus 3, that would be factored form. So it's the same thing we've been doing over and over again. Factored form, standard form, factored form, standard form. So this would be in the standard form because we expanded it out. We multiplied it out using the pattern of the x decreasing and the 3's increasing and the coefficients 1, 6, 4, 1. Now we're going to do b. b is 3 minus z to the third power. So we got a negative in there to keep track of. The coefficients this time are 1, 3, 3, 1, 1, 3, 3, 1. So we use the row with the 3 in it. So it's 1, 3, 3, 1. I'm going to write that right here. 1, 3, 3, 1, just so I remember, is equal to, so here we go. 1, first thing, is 3 to the third power. So it's like first thing, second thing. Plus 3 to the second power. Now we bring in a z, but we got to bring in negative z. Negative z to the first power. Plus, next thing, 3, and then 3 to the first power, and then negative z to the second power. Plus 1, negative z to the third. So I still have the pattern going here, 1, 3, 3, 1, z to the, 3 to the third, 3 to the second, 3 to the first, no 3, z, no z here, negative z to the first, negative z to the second, negative z to the third. So it's matching all the pattern. Now we're going to simplify this following the order of operations. And again, this is factored form. I'm expanding it out into standard form. 3 to the third power would be 27 times 1 is 27 plus, that'd be 9 times 3 would be another 27 with a negative z, so it'd be negative 27z. So I'm going to erase the negative plus there, make negative 27z. And then when you square, we got to always follow the order of operations. So I square the negative, which is positive. So it's 3 times 3 is 9, and that's not positive. So it's plus 9z squared. And then a negative cubed is negative. So it's negative z to the third. So this would be standard form, that's factored form, and those are equivalent.